Hello everyone, we're back with Propositional Logic, Chapter 6. I trust you're doing well and staying out of harm's way. I wanted to start with truth functions first, which occur on pages 342 to 344. A truth function is a compound statement which depends upon the truth or falsity of its components. And so, just to go over these, if you haven't already, we'll do by Tuesday, we'll do truth tables, by the way, that'll be 6.3. The symbol of negation in logic occurs like this, P and not P. So those are the two possible values for P, true and false, and then not P, well, if P is true, then not P is false, because you just negate what's the true. And if P is false, then not P, which would be not F, would be true. So those are the functions for negation. The negation sign or tilde in front of an expression just means it is false that whatever follows. It is false that. Conjunction uses the dot instead of the symbol of negation, and so if you're talking about a conjunction of two variables P and Q, there are four possible values for how P and Q could fit together. They could both be true, as on the first row. One could be true, one false, as on the second row. First false, the second true, and then both false. So if you have a conjunction symbol, dot, that means that both components must be true for the entire truth function to be true. So T dot T would make T, true and P and Q together. It's only true when they're both true. Similar to if I say it's going to be cold and sunny today, it has to be cold and sunny for that entire statement to be true. If it's just cold but not sunny, or not cold but sunny, the whole statement is false. If P is true and Q is false, that's false, because again, the dot means they both have to be true. If P is false and Q is true, that's false, and if they're both false, it's false again. So that's how those values work so far, but you have three more operators: the wedge, the symbol of implication, the horseshoe, and then the biconditional. So let's try those and see how it would work with those. So let's take the wedge first. The wedge, or the symbol of disjunction, means that one part of the sentence has to be true. So if I say P is true or Q is true, which is how that's read in English, at least one part of that must be true. So if I say it's going to be cold and sunny today, only one of them has to be true, if it's going to be cold or sunny, rather. If it's just cold, that would fulfill the truth requirement for that sentence. If it's sunny, that would also fill the truth requirement. So, true or true, obviously, would make true, because you only need one to be true. If P is true and Q is false, then P or Q is also true. If P is false and Q is true, that is also true. When is it false? Only when they're both false, because remember, the or was a guarantee. The symbol of disjunction was a guarantee that one or the other of the disjunction, that is to say the two parts of the expression, would be true. So if they're both false, that violates that particular promise, and that's when it's false. Let's now move out the symbol of disjunction and take the symbol of implication, which is, he has it as a horseshoe. In a keyboard you can do the sideways wedge. When is a symbol of implication true? Well, it's true if the antecedent is true and the consequent is true, it's automatically true. We can think of it by process of elimination. The only time it's false is when the antecedent part is true, or the P part in this case, and the consequent part is false. So it says, if P is true, then Q is true. That's how it's read. It'll help you to think of it that way. If P, then Q, or if P is true, then Q is true. P is true and Q is true, that's true. When is it false? When P is true and the antecedent is true, what comes before the wedge is true, and what comes after the wedge is false. So that is false. So because, what did the expression say? If the antecedent is true, then the consequent is true. When is that violated? When the antecedent is true and the consequent is false. If the antecedent is false and the consequent is true, that's true. And if the antecedent is false and the consequent is false, that is true also. Why? Think of it again as making a promise. If the P part is true, then the Q part must be true also. That doesn't apply. You get a pass when the antecedent part, in this case the P, is false. So that's the truth function for the wedge, or sometimes called the symbol of implication, because it really says P implies true. You can read it that way too. P implies Q. Now let's take the biconditional, the triple bar, or the equivalent to, sometimes will appear like this on the keyboard, two sideways wedges, but what does that mean? Well, P is equivalent to true, or P if and only if Q, as we saw recently. So true, if P is true and Q is true, then P is true if and only if Q is true. In this case, it's true. When is it true? When those two values are equivalent. If they're both true, we get it true. But if P is true if and only if Q is true, then and if Q is false, then that's false. Why? Because P and Q are not equivalent. If P is false and Q is true, they're not equivalent, that's false. And if P is false and Q is false, they're both equivalent there, so that's true. So P if and only if Q, they have to have equivalent values. They have to have identical values. If you want to think of it as identity, that's fine too. That'll work. Okay, so armed with those truth functions, then let's look at some of the problems that you were asked to do. 6.2 Roman numeral 1 will be the first set. And okay, you're asked there to identify the main operator in each of the following propositions. Identify the main operator. Let's see what the main operator is. Well, what do we mean by the main operator? He explains that the main operator is the operator that governs the largest part of the formula. The operators are AND, or a negation, or implication, or biconditional, or which. In this case, clearly, the main operator in the first one is the dot, even though I didn't ask you to do the first one there because it's been done for you, but the dot governs the whole formula. How about number 2? You were asked to do that. What operator governs the entire formula there? In number 2, it's the horseshoe, if you want to use the language that he uses. I just say symbol of implication, but horseshoe is just one word, so that's fine. What about number 3? What's the operator that governs the largest part of the formula? Well, the negation side is outside the parentheses, so that governs all that's in there. Whatever value you would find inside, the negation would apply to. So clearly there, then it's the tilde, as he calls it, the symbol of negation. And then you skip number 4, it's done. Then you go to number 5. What's the main operator there? Well, again, the main operator is that governs the largest part of the formula. You might think of that first negation sign as doing that, but that would be wrong. The negation only governs what follows, that is to say what's in the parentheses. The disjunction just prior to the negation sign, that is the wedge, if you want to write a shorter word, that is the main operator. It governs the entire first part. It says the first part or the second part will be true. Now what about the next part? Well, you might look quickly, and I don't recommend that. You might think the symbol of implication or the horseshoe there in the middle of the formula in number 6. Again, we're on page 351, 6.21. That the symbol of implication there is the major operator, but it's not. The negation sign outside the brackets, notice, applies to the whole thing. So again, it's the tilde, or symbol of negation. Skip 7, and then look at 8 and 9. Well, 8, you have there some whole disjunction inside of brackets, and then a if and only if, or a triple bar, and then not H. Well, clearly there, the triple bar, or the, I'm just going to write it, is the main operator in this case, governs the largest part of the formula. What could you say about 9? Well, 9, interestingly enough, you have E dot or E and everything that follows. Well, that dot then, or that symbol of conjunction that we talked about a moment ago, governs the entire formula, the first conjunct with the second. So you just put dot there would be the main operator, and that's all you need to do for 6.21. 6.22, you're challenged to do a bit more here, so let's try those next. 6.2, Roman numeral 2. Write the following compound statements in symbolic form, then use your knowledge of the historical events referred to by the simple statements to determine the truth value of the compound statements. Truth value meaning there are 2 truth values, he says sometimes. I like to think of a third unknown, but true and false are the 2 truth values. Well, the first one is done for you. It is not the case that Hitler ran the Third Reich. You would just put not H in that case if you haven't looked it up already. The second one says Nixon resigned the presidency and Lincoln wrote the Gettysburg Address. So let's put N for Nixon and L for Lincoln wrote the Gettysburg Address. Now, what is the truth value of those statements? Well, Nixon did resign the presidency, that's true, and Lincoln did write the Gettysburg Address, that's true. So true and true makes true. So that conjunction is true. Both, in a conjunction, remember, both have to be true, but they both are true in that instance. How about number 3? France bombed Pearl Harbor or Lindbergh crossed the Atlantic. Well, France bombed Pearl Harbor would be F, or Lindbergh crossed the Atlantic would be L. Okay, did France bomb Pearl Harbor? No, that's a false. Did Lindbergh cross the Atlantic in a small plane? Yes, he did. And that's false or true, and that makes true. Why true in this case? Because again, the truth function for or, only one of the disjuncts has to be true. And since the Lindbergh part is true, that's fulfilled that requirement. Let's skip to 5. 5 says Edison invented the telephone or Custer was killed by the Indians. Edison, so that would be E or C. Edison did not invent the telephone, it's Alexander Graham Bell, so that's a false. Or Custer was killed by the Indians, that's true. What is false or true? Well, we know it was true there, so it must be true again. It'll be true a million years from now. False or true, one of the disjuncts has to be true, so the whole thing is true. Let's go to number 6. Julius Caesar conquered America if Napoleon ruled France. Okay, so we start with it's kind of reading this one backward, right? If this antecedent Napoleon ruled France, then the consequent Julius Caesar conquered America. So if Napoleon ruled, that's if N, then Julius Caesar conquered America, let's say J. Well, Napoleon did rule France, that's true. Julius Caesar did not conquer America. He's a little too early for that. True implies false, so true implies false according to implications are false, you'll remember. Okay, so that's how that one would work. So going back to again, the horseshoe, T implies F is the only time that the implication would be false. Okay, we have 2 more, it's numbers 8 and 9. Let's try 8. Okay, so 8 says, Lincoln wrote the Gettysburg Address if and only if France bombed Pearl Harbor. Well, we know if and only if triggers the triple bar in our mind, so Lincoln wrote the Gettysburg Address if and only if France bombed Pearl Harbor would be L, triple bar, France bombed Pearl Harbor, France equal F. Well, Lincoln did write the Gettysburg Address, that's true. Triple bar, did France bomb Pearl Harbor? No, they did not. That's false. So T, triple bar F, when is that true? They both have to have the same truth value, both F or both T, so that is false. Finally, number 9 says that it is not the case that either Julius Caesar conquered America or Washington was assassinated. So that would be, it is not the case that some disjunction, either Julius Caesar conquered America, okay, so let's put J, or France, or Washington was assassinated, or W. Well, let's just do the work inside the parentheses first. Not J or W. Julius Caesar conquered America is in fact false, or Washington was assassinated, that's also false. So false or false makes false, and then you apply the negation, and negation to false is in fact, in this case, true. So that whole expression is true. Why, if you want me to go through it again, it is the 9 is not the case that Julius Caesar conquered America or Washington was assassinated, not J or W. And what's the value of J in this case, that Julius Caesar conquered F, and France bombed F or F. So keep the negation outside until you do the work inside the parentheses. F or F is F, and finally the negation of F is T. So the whole thing then would be true based on your knowledge of these historical events. Okay, there's 2 more parts to do. 6.23 and then 6.24. Here, I call these substitution exercises, where we substitute a set of values to do the problems. You'll see that after you get going with it, it's not so difficult. So 1 is done for you, and it says here that whenever you see A, B, and C, that you let those equal true. whenever you see x, y, and z, you let those equal false. Okay, clear enough. So number 2 says b is true and y is false. So true and not false. True and not false is true from our knowledge of negation. So that is true. So number 2 is true then. True and not false. Okay. Number 3. X or not y. Okay. X is false or not false. Okay. So it's false or do each line bring the work down. False or not false, false or true. With a disjunction, if one of the disjunctions is true, what's the value? True. False or true makes true. Okay, and then we go on to 5. 5 says B is true implies Z is false. Okay, whenever I see B, I substitute true, and that implies that not false in this case, so true implies not false, so that not false is true, true implies true is true. Look at your truth functions, true implies true is always true. It's only false when it says true implies false. Okay, 6. You have here y implies not A. Okay, I know that when I see y, it's F implies A is false, and A, whenever I see A, I substitute true. So F implies F, and our knowledge of implication tells us that F implies F is in fact true. Shorthand, it's only false when true implies false. Okay, then we're up to number 8. We're going to skip 7 because it's done already, and then number 8. Okay, so 8 is an equivalence, so B triple bar Y. Okay, well that's true for B and false for Y, and Y is that's false there. So is true equivalent to false? No, that's false. And then number 9, not C is equivalent to Z. Well, not C is not T is equivalent to F. That looks right. Not T is F is equivalent to F. So that one was in fact true. Okay. But we do 2 more there. Numbers 11 and 12. They being a bit longer. Okay, you have not B, or, which is the main operator here, Y implies A. Okay, not B is not true, or F implies true. Okay, not true is false, or F implies true. If there's F in the antecedent, it's automatically true. F or T is true. So F or T is automatically true. That we know that one to be the case. Okay, so, and then number 12, also a long formula, but the same principles, the same truth functions hold. So now number 12, the final one of 6.23, goes like this. A implies not, and then in the parentheses, Z or not Y. Okay, so A is true, implies not F or not F, okay, like that. True implies not F or T. So bring it down again. True implies not T or F is T. True implies not T is false. T implies F is F. Remember, the implication always works in such a way that if the antecedent is true and the consequent is false, then it is false. Okay, so there we substituted true and false values. Now we're going to add one more wrinkle to this. That is 6.24. We're going to determine the truth values of the following statements. Let A and B be true. Okay, so we're going to keep that part. A and B equal true. Okay, and then when you see X, or Y and Z rather, Y and Z equal false, and then you have P and Q are unknown. There's the new part, is that whenever we see the letter P or the letter Q, we will substitute a value unknown. I do think of, contrary to the author, I do think of unknown as a truth value. If you say it's going to rain at 3 o'clock today, that's neither true nor false, it's unknown. So I do think of that as having its own truth value. But if you define truth values as only being T or F, then that's why you'll say what the author says here. Okay, so 6.2, Roman numeral 4, let's do 2. Number 2, what you're asked to do is Q or Z. Q is unknown, and Z is F. So, do we know what unknown will be? It could be true, it could be false. We don't know, so unknown or F equals unknown. For example, if it was true, it's only 2 possible values for the unknown. True or false would make true. But if it was false, false or false would make false. We don't know which, so we just have to say unknown, don't we? How about 3? 3 is Q and or Q dot Y. Q is, in this case, P, or unknown, and Y is F. Well, the dot says that both must be true, so it should trigger in your mind that this has to be, regardless of the value of the unknown, whether true or false has to be false, because at least one of the conjuncts, the latter one, Y, is F, so it makes the problem F. Let's skip to number 5. P implies B. Well, here we have an unknown implies, in this case, true. Well, that should trigger something for you. If the consequent is true, then the whole expression is true. No matter if this was true, true implies true would make true. If unknown was false, false implies true is true. Doesn't matter. Either way, it will be true. 6 is Q. Z implies Q. Okay, Z we say is equal to F. I know what this is. And Q is unknown. Well, F automatically, F in the antecedent means the whole thing is true, regardless of this is true or false. False implies true is true, false implies false is true. So in this instance, it's automatically going to be true. Anything false in the antecedent is automatically makes a conditional true. Again, shorthand, it's only false when true in the antecedent and false in the consequent. All right, let's skip to number 8. 8 is an interesting application of a famous law. It says P is equivalent to not P. Can anything be equivalent to its own negation, I ask you? No. It violates Aristotle's law of non-contradiction. So P in this case, let's just follow it through. P is unknown. Can something unknown be equal to something not unknown? To say it's not unknown means it's known. And if it's known, then it's either true or false. So the law of non-contradiction, Aristotle says something P and not P cannot be true at the same time. So it's always false that something and its negation would be the case. It's raining and it's not raining, for instance, can never be the case. And so Aristotle would capture that by saying it's false that something and its negation could possibly be true, called the law of non-contradiction, one of his 3 laws of thought. 9, let's do 9 here. 9 says P implies A, which then implies Z. Well, let's see about that. U implies A, which is true, implies Z, which is false. Well, U implies T, anything with T in the antecedent, no matter what what the U stands for, U implies T is T, and T implies F, we know, violates the conditional. Conditional says if the antecedent is true, the consequent will be true also. In this case, it's false. So this one, number 9, happens to be, in this instance, false. 11 and 12 get to be quite long, but nothing has changed. They're just, you have to hang with them for a few more steps. And you do have to show the work, of course, in these. 11, so Q implies B, which then implies A implies Y. Okay, so Q implies B, substitute for unknown implies true implies F. Okay, unknown implies true is true. Anything with a T in the consequent or after the horseshoe is true. True implies T implies F is false. True implies F, keep the parentheses, true implies F is false in this case. So that's number, what did we say that was, 11. I think there's one more, and that would be 12. Okay, so number 12 goes like this. Negation, or it is false that P implies Y, or Z implies Q. Okay, so it's false that whatever's inside those parentheses, do the work in the parentheses first. U implies false, or Z, in this case false, implies Q, which is U. Okay, keep the negation outside. U implies F, we don't know what U will equal. It could be a true, which would make that false. So we say it's unknown. Or F implies U. In this case, F in the antecedent is automatically makes this true. So is true. So not U makes this, let's just keep it not U or T. Well, not U or T, it doesn't matter what U is equal to, does it? Because in this case we have a T in the second disjunct, which makes the whole thing true. Okay, don't think I did anything. No, that in fact is true. All right, so we've done those exercises, folks, 6.2, 1 through 4. Now you want to try the truth table part, and I'll be back to you on Tuesday with the trying truth tables. That's the working towards testing arguments via truth tables. Be well until then. I'll see you then. Bye-bye.